Okay, today in topic 7.3 of solving absolute value equations. Today is day 2. Yesterday we looked at solving some simple ones. Today we're going to get into a little bit more complicated. Before we do that, we just want to examine something that's a little bit different than you've seen before. If we asked you to solve the absolute value of x squared minus 4 is equal to 5 graphically, we would graph the left side, the absolute value of x squared minus 4. Now, x squared minus 4 is a parabola. The bottom of the parabola should go down to negative 4. However, the part of the graph that gets below the x-axis is going to be flipped over the x-axis to be a positive. So it's going to look something like this. We can figure out our points. And when we plot our points, you're going to see that in between negative 2 and positive 2, they're going to go upwards instead of downwards. That's the part of the graph that's changed to positive that we would expect to be negative. If I drew it in red, you can just faintly see what it would normally have looked like. Now you can see that there's going to be two solutions. One of the solutions appears to be when x is negative 3, and the other appears to be when x is equal to positive 3. In example 1, we're going to solve the absolute value of x minus 3 is equal to 7. Case 1 is the positive. X minus 3 is equal to 7. So x will equal 10 over on that side. Case 2, we got the negative of x minus 3 is equal to 7, which means negative x plus 3 is 7. So negative x is going to equal 4. So x will equal negative 4. Again, you have to verify if you're using algebraic method, and we have 10 minus 3. The absolute value of 10 minus 3 is 7, and 7 is 7. And again, both of these ways work. So we have two solutions. If we just wanted to have a look at this and graph it, you're going to see in your calculators, you can generate some ordered pairs. 3, 0 is our invariant point, and you're going to see that there's two solutions. One of them is at x equals 10, the other one's at x equals negative 4. Moving on to example 3, let's solve the absolute value of 2x minus 5 is equal to 5 minus 3x. In case 1, we're going to have the positive, 2x minus 5 is 5 minus 3x. And in case 2, we're going to have the negative. Negative 2x minus 5 is equal to 5 minus 3x. In the first case, we're going to add 3x to both sides. Now we're going to add 5 to both sides and divide both sides by 5 to get x equals 2. To verify it, 2 times 2 minus 5 is 5 minus 3 times 2, which gives us the absolute value of 4 minus 5 is equal to 5 minus 3 times 2. The absolute value of 4 minus 5 is negative 1. And we're going to get 1 equals negative 1. Therefore, there's no. Throw it up. Next one. Negative 2x. The negative of negative 5 becomes plus 5 equals 5 minus 3x. Now you can add 3x to both sides to get 1x plus 5 is 5. Subtract 5 from both sides to get x equals 0. We can verify this one now. 2 times 0 minus 5 gives me the absolute value of negative 5, which is 5. 5 minus 3 times 0 on the other side, we get 5 equals 5. That one works, so x equals 0 is our only solution. If we graphed this, what does it look like? Well, you're going to get two equations. If we plot some points and lay them out on our graph, you are going to see that there is our first graph, y equals the absolute value of 2x minus 5, and here is the line 5 minus y equals 5 minus 3x. And you'll see that the way they're shaped, there can only be one intersection point, therefore there's only one solution. In example 4, we're going to look at the absolute value equations with no solutions. Here we're told that the absolute value of 3x minus 4 plus 12 is equal to 9. In our first case, we're going to have 3x minus 4 plus 12 is 9. And the other case is the negative of 3x minus 4 plus 12 equals 9. In the first one, we're going to clean it up and get 3x minus 8 equals 9. 3x equals 1. And dividing both sides by 3, x equals 1/3. On the other side, we're going to get negative 3x plus 4 plus 12 is 9. 4 and 12 is 16. And now we can subtract 16 from both sides. And negative 3x is negative 7. Divide both sides by negative 3, and x will equal positive 7/3. When you verify, neither of them are going to work. Therefore, we can have a look at this graph and see what's happening. Here we have our x and y axes. On our first graph of the absolute value of 3x minus 4 plus 12 means that the whole thing is going to be shifted up 12 units, so that the bottom of our absolute value function is going to be at 12. There it is. Our other side is going to be the line y equals 9. There it is. As you can see, there's no intersection points, therefore there's no solution. In example 5, we're asked to solve the absolute value of x squared minus 2x equals 1. In case 1, we're going to have the positive of x squared minus 2x equals 1. If you bring the 1 over to the one side, you're going to get x squared minus 2x minus 1 is equal to 0. Yes, it's a quadratic equation. And we can't factor it, so we have to use our quadratic formula to figure out what our values are going to be for x. And x is going to be 1 plus or minus root 2. So there's two possible solutions for that case. If you verified it and substituted it and took the time, you would get 1 is equal to 1, so it does work. And for 1 minus root 2 of squared, minus 2 times 1 minus root 2 equals 1, and then you took the time, plugged it in your calculator to verify those numbers, you're going to get, again, 1 is equal to 1. So both of these verify in case 1. In case 2, we're going to have the negative of x squared minus 2x is equal to 1. Take away the brackets, negative x squared plus 2x equals 1. Bring everything over to the right side to make a positive x squared. Next is going to give me x squared minus 2x plus 1 equals 0. This one is factorable. I get x minus 1 and x minus 1 is going to equal 0. So this time I have one solution in case 2, and that is going to be x equals 1. I have to verify this one. Substitute it back in there, and you're going to find that the absolute value of negative 1 is equal to 1, or 1 is equal to 1. The solutions are x is equal to 1 plus root 2, 1 minus root 2, and 1 in exact form. If we drew this graph, here's what it's going to look like. Plotting these points and drawing it out, you're going to see that there are going to be 3 points of intersection. The first one is x equals 1 minus root 2. The one in the middle is where it's x equals 1. And the one on the right side is going to be where it's 1 plus root 2. So those are 3 solutions. Example 6. Solving the absolute value of x minus 10 is equal to x squared minus 10x. X minus 10 is equal to x squared minus 10x. Clean this all up, and you get x squared minus 11x plus 10 equals 0. Is this factorable? Yes, it is. So I got two possible solutions, x equals 10 or x equals 1. In the negative case, we're going to have the negative of x minus 10 is equal to x squared minus 10x. So that's negative x plus 10 equals x squared minus 10x. Gather everything on the right side, and you're going to have x squared minus 9x minus 10 equals 0. And this is also factorable. X is equal to negative 10 and x plus 1. X equal positive 10 or x equals negative 1 are our two candidates for solutions. Now, here we have 10 in both of them, so we only have to test that one once. And we have 1 and negative 1, so we've got to test all three. For 10, you get 0 is equal to 0. That works. For 1, you're going to get negative 9 is equal to positive 9. That doesn't work. And for the last one, you're going to get 11 is equal to 11. That one works. So the roots are 10 and negative 1. If I change the numbers on my graph here to go from negative 20 to positive 20 in both directions, I can graph this, and you can see now that there's going to be two places where these graphs are going to intersect. And the first so you can see our parabola and absolute value function can cross at x equals 10 and x equals negative 1. Our assignment is page 389, 6 to 11, 13, and 15.